Hello again, my dear students of first secondary. Today we are going to complete our lesson about determining the types of roots of the quadratic equation. Okay, so this is part 2 of finding or determining the types of roots of the quadratic equation. Let's go. Example 5. Prove that the two roots of the equation 2x power of 2 minus 3x plus 2 equals 0 are complex and not real. Then use the general formula to find those two roots. Here we want first to prove that the two roots of the equations are complex. How can we prove that the two roots of the equation 2x power of 2 minus 3x plus 2 equals 0 are two complex numbers? Very good, excellent. By using the discriminant. First we are going to calculate the discriminant. If the discriminant is positive, then the two roots are very good, are two real and different. If the discriminant equals 0, so the two roots will be very good, will be different and equal. But if the discriminant equals a negative number, then the two roots of the quadratic equation are complex and two conjugate roots. Okay? So now we are going to calculate the discriminant together. Okay? We are going to calculate the discriminant together. Okay? And you will find that the value of the discriminant will be negative. The value of the discriminant will be negative. Okay? So we can say that the complex, then we can say that the two roots are complex. Okay? Let's check it together here. Okay? Here you can see that A equals 2, B equals negative 3, and C equals 2. Okay? Let's calculate the discriminant. Discriminant equals B power 2 minus 4AC. B power 2 negative 3 power 2 equals 9. Minus 4 multiplied by A, 2 multiplied by C equals 2. This equals to 9 minus 4 times 2, 8. 8 times 2 equals 16. 9 minus 16, it will be equals to negative 7. Since the discriminant is a negative number, then the quadratic equation has two complex and not real roots. Okay? Then he asked you to use the general formula to find those two roots, and it will be easy for you to find the two roots by using the formula. Let's solve this example again by using the PowerPoint. 2x power of 2 minus 3x plus 2 equals 0. Okay? A equals 2, B equals negative 3, C equals 2. Discriminant B power 2 minus 4AC will be equals negative 3 power of 2 minus 4 multiplied by 2 multiplied by 2, and the result will be 9 minus 16 equals negative 7. Here all we care about is the sign of the discriminant. Here the discriminant equals negative 7, so its sign is negative, so the quadratic equation, the two roots are complex and not real roots. Okay? How can we find the two roots of the quadratic equation? Now we are going to using the general formula. X equals negative b, positive or negative root discriminant. What is the root? D means root the discriminant, which is equals to b power 2 minus 4ac. All of this over 2a. Substitute negative b. Negative b will be equals to negative 3 for all power of 2, which is equals to 9. Positive or negative the discriminant, which is equals to negative 7. Okay, the discriminant equals negative 7 over 2a. Here you have to revise what we are studied before. Here you have negative 7 under the square root, but you are solving this equation or you are solving this example in the set of complex number. So negative root 7, how can we find the square root of negative 7? Okay, I will give you a hint. Square root negative 7 can be written as square root 7 multiplied by square root of negative 1. Square root 7 will be written as it is, and we will replace the square root of negative 1 by the imaginary number I. Okay, so the square root of negative 7 will be square root 7I. All of this equals 4. Okay, then you have to simplify x as x equals 3 plus root 7I over 4 and 3 minus root 7I over 4. Okay? Okay, here 3 positive or negative root 7I over 4. The two roots are 3 plus root 7I over 4 and 3 minus root 7I over 4. Okay? This is the two roots of the quadratic equation. Okay, let's go to another example. Find the value of k belongs to R, which makes the two roots of the equation x power of 2 minus kx plus 2k minus 4x plus 5 equal. Okay, again he wants to find the value of k. What is k? Is a number belongs to R, which makes the two roots of the equation x power of 2 minus kx plus 2k minus 4x plus 5 are equal. First, since the two roots are equal, then the discriminant must be equal 0. The two roots are equal, then the discriminant must be equal 0. But here first you have to put x squared, the given equation, in the form of a quadratic equation, in the standard form of the quadratic equation. So here you have to rearrange the quadratic equation. You will write x power of 2 as it is. Here we have negative kx and we have negative 4x. So we will write negative kx and negative 4x, each one besides the other. And what is the term free of x? The term free of x here is 2k plus 5. 2k plus 5, this is the term free of x. Okay? Now, a will be, first we are going to take negative x as a common factor from the two, from negative kx minus 4x, we will take negative x as a common factor. Okay? Let's do it together. Here you have x power of 2 minus, here we have negative kx minus 4x. The two terms here, negative kx minus 4x. We will take negative x as a common factor. So we will divide negative kx divided negative x, it will be k. Negative 4x divided negative x, the result will be positive 4. Okay? Let's write the quadratic equation in the standard form. Okay? Here the discriminant will be b power 2 minus 4ac. Okay? Here a equals 1 and b will be equals to negative k plus 4. Okay? The coefficient of x will be k plus 4. The discriminant will be b power 2, b power of 2. Okay? What is the coefficient of x? The coefficient of x is x plus 4, x plus 4 power 2. Okay? Just a moment, please. Let's explain it together, step by step. Okay? This is one of the important example and one of the difficult example in this lesson. Okay, let's solve it together first, step by step. Then we are going to solve it again by using the PowerPoint. Okay. Okay. We will write the quadratic equation again. X power of 2. Okay, we will take negative x as a common factor, so it will be k plus 4, and the free term will be 2k plus 5. All of this equals to 0. Okay, here a is the coefficient of x power of 2 equals 1. B here is the coefficient of x. The coefficient of x here is negative k plus 4. Coefficient of x here is negative and k plus 4. And the free term c will be equals to 2k plus 5. Okay, the discriminant here is b power 2 minus 4ac. Let's calculate it together. Discriminant equals b power 2. Where is b? b is negative, and we have bracket x plus 4. If we are trying to getting b power 2, here we are going to square negative k plus 4. The power 2 will cancel the negative, and the result will be k plus 4 for all power of 2. Okay, here you have b equals negative and bracket k plus 4. We are going to square this bracket, so the negative sign will disappear because negative 1 to the power of 2 equals 1. K plus 4 power of 2, it will be k plus 4 for all power of 2. Okay, which is equals to k power 2 plus 16, the third term. First times second times 2, it will be equals to 8k. Okay, all of this is equals to b power of 2 minus 4 multiplied by a here equals 1, and multiplied by c, which is equals to 2k plus 5. Okay, let's solve it together again by using the PowerPoint. Okay, step by step again. Step by step again. Here c equals to k plus 5. Okay, the discriminant will be b power of 2 minus 4ac. Here b, it will be. Here I simplified very quickly and write, instead of negative k plus 4 for all power of 2, I write it as k plus 4 for all power of 2, because I know that the power 2 will cancel the negative sign. Minus 4 multiplied by a is the coefficient of x power of 2, which is equals to 1, multiplied by c, which is 2k plus 5. Okay, we are going to expand the bracket, x plus 4 for all power of 2. Okay, it will be k power of 2 plus 8x, it will be k power of 2. Let's erase this. Okay, here k power of 2 will be equals to k power of 2. 4 power of 2 equals 16. First times second times 2, it will be equals to 8k. Negative 4 multiplied by 1 equals negative 4. We are going to distribute negative 4 over the two terms of the bracket. Negative 4 multiplied by 2k is equals to negative 8k. Negative 4 multiplied by 5, this is equals to negative 20. Okay, collecting like terms, you can find that negative 8k will cancel 8k. So you will have k power of 2 and 16 minus 20, this is equals to negative 4. So the discriminant here the discriminant here will be equals to k power of 2 minus 4. Since the quadratic equation has two equal roots, then the discriminant will be equals to 0. Okay? The discriminant equals 0. That is to say that k power of 2 minus 4 equals 0. Negative 4 will go to the other side. Okay? So k power 2 equals 4. So k will be equals to positive or negative 2. Okay? Here we want to find the value of k which belongs to R. So k equals positive or negative 2. Okay? This is a difficult one, and we are going to solve another example like this. Here, in this example, he wants to find the value of k if the two roots of the quadratic equation are real and different. Find the value of k if the two roots of the equation x power of 2 plus 4x plus k equals 0 are real and different. Okay? Since the two roots are real and different, that is to say that the discriminant is positive. Okay? Here is another meaning of the discriminant is positive. The discriminant is positive means that the discriminant is bigger than 0. Okay? So we will write the discriminant bigger than 0. That is to say that b power 2 minus 4ac bigger than 0. Okay? Here we have a equals 1, b equals 4, and c equals k. Okay? Let's substitute. b power 2, 4 power of 2, minus 4 multiplied by a, 1 multiplied by c, which is k. All of these bigger than or equal 0. 4 power of 2, 16. Negative 4 times 1 equals negative 4. Negative 4 multiplied by k, this is equals to negative 4k. So now we have 16 minus 4k bigger than 0. 16 minus 4k bigger than 0. 4k will go to the other side. So 16 will be bigger than 4k. 16 bigger than 4k. Divide the both terms of the inequality by 4. If we divide by 4, 16 divided by 4, it will be equals to 4. 4k divided by 4, this is equals to 1k. So now we have 4 bigger than k. Since 4 is bigger than k, that is to say that k is all the numbers which is smaller than 4. Here k is smaller than 4. So k is all the numbers which are smaller than 4. So we can write it as an interval. K is all the values which are smaller than 4. So k belongs to the interval from negative infinity to 4. Okay? K is smaller than 4. So k belongs to negative infinity and 4. Okay? This is one of the important example. You can find it in each exam. Okay? He will ask you to find the value of k of the two roots where k is not a number. K is an interval. Is more than one number. Okay? So k belongs to the interval from negative infinity to 4. So if you replace k in this example by any number belongs to the interval from negative a to 4, like negative 10, negative 20, negative 100, and you write the equation x power of 2 plus 4x minus 100 equals 0, you will find that the two roots of the equation are real and different. Okay? Let's take another example. Find the value of k in if the two roots of the equation kx power of 2 minus 8x plus 16 equals 0 are complex and not real. Okay? The two roots of the equation are complex and not real. Okay? Since the roots of the quadratic equation are complex and not real, this is mean the discriminant is negative. Okay? How can we write the discriminant is a negative number? So the discriminant is a number smaller than 0. The discriminant is a number smaller than 0. Okay? Okay. Solution. The two roots are complex and not real. The discriminant smaller than 0. That is to say that b power 2 minus 4ac smaller than 0. Okay? Here you have a equals k, b equals negative 8, c equals 16. Substitute b power 2 negative 8 power 2 minus 4 multiplied by a equals k, c is the free term which is equals to 16. So you will find that negative a power 2 equals 64, negative 4 multiplied by k multiplied by 16, it will be negative 64k. So now we have 64 minus 64k smaller than 0. Okay, negative 64 will go to the other side, so it will be 64 smaller than 64k. Here we want to find the value of k, so we are going to divide the both terms of the inequality by 64. Divided by 64, so you will find that k bigger than 1. K bigger than 1. So k is all the numbers belongs to R which are bigger than 1. So k may be equals 2 or 3, 4, 5, 6, 7 and so on. How can we write this? We can write this in the form of interval k bigger than 1. So k belongs to all the numbers bigger than 1 from 1 open to infinity. 1 open to infinity. Why 1 is an open interval? If you have an equal sign here under the smaller sign or bigger sign, if you have an equal sign, so you will put 1 closed. Okay? But here you don't have an equal sign, so you will write from 1 open to infinity open. Okay? So your answer will be k belongs to the interval 1 open and infinity. We all know that infinity is always open, so from 1 to infinity. Okay? Let's go to another example. Here, exercise, you can do it by yourself. If the equation x power of 2 equals k plus 2 has two real and different roots. What do we mean by it has two real and different roots? This is to say that the discriminant is positive. The discriminant is positive means that the discriminant is bigger than 0. Okay? Solve it by yourself and you will find that k must be belongs to negative 2 open to infinity. Okay? Another example. Find the values of the real number m that satisfies the equation m minus 1 x power of 2 minus 2mx plus m has no real roots. Has no real roots. Okay? Again, he wants us to find the values of m. Okay? Which makes the quadratic equation has no real roots. Okay, mister. What do we mean by it has no real roots? Here, we mean by it has no real roots that the discriminant is negative. The discriminant is negative. Okay? That is to say that the discriminant that is to say that the discriminant is smaller than 0. Okay? Here, the discriminant smaller than 0. This is a very tough example. Okay? Focus with me. Okay. Here we have A. Here we have A equals m minus 1. Okay? B is the coefficient of x equals to negative 2. C is the free term which is equals to m. The two roots here, the two roots are complex. That is to say that the discriminant is smaller than 0. Okay? So the discriminant, which is b power 2 minus 4ac, smaller than 0. Okay? b power 2, here b equals to negative 2m. b power 2 means negative 2m for all power of 2. Minus 4 multiplied by a equals to m minus 1. Multiplied by c, which is equals to m. All of this smaller than 0. Negative 2m power of 2 is equals to 4m power of 2. Here, minus 4 multiplied by m, it will be equals to negative 4m. Negative 4m multiplied by m, it will be negative 4m squared. Negative 4m multiplied by negative 1, this is equal to positive 4m. All of these smaller than 0. Here you can see that 4m squared will cancel negative 4m squared. So we have 4m smaller than 0. Divide both sides by 4, so you will find that m smaller than 0. So m is all the numbers which are smaller than 0. What are the numbers which are smaller than 0? You have negative 1, negative 2, negative 3, negative 4, negative 5, and so on. And here we don't have an equal sign, so m will belongs to the interval from negative infinity open to 0 open. Okay? Let's solve it again by using the PowerPoint. Okay? Solution. The equation has no real roots. So the discriminant smaller than 0. b square minus 4ac smaller than 0. A equals m minus 1. B equals negative 2m. And C equals m. By substituting in the discriminant, you will find that negative 2m power of 2 minus 4 multiplied m minus 1 multiplied by m smaller than 0. Here again negative 2m for all power of 2. First power 2 will cancel the negative. 2 power 2 will be equals 4. M power 2 will be equals to m power 2. Okay? So 4m power of 2 minus here 4m power of 2 plus 4m smaller than 0. 4m will cancel negative 4m smaller than 0. So m will be smaller than 0. Okay? Okay, m smaller than 0, so m will belong to the open interval from negative infinity to 0. Okay? So you can see that the two methods help each other. The two methods help each other. First, we are solved it together by using the handwriting. So we are going to solve it by handwriting, then by using the PowerPoint, and the two methods complete each other. Okay? Let's go to another example. Very important remark. This is the last idea in this lesson. Okay? Very important remark. In the quadratic equation, ax power of 2 plus bx plus c equals 0, if a and b and c are rational, if a, b, and c are rational numbers. What's the rational numbers? Rational numbers means belongs to Q. The rational numbers is the set of numbers belongs to Q. So here, what are the rational numbers? Rational numbers means fraction. Rational numbers here means fraction, decimal, maybe fraction, maybe decimal. Okay? This is the Q. Or any number can be written in the form of A over B, fraction or decimal. Okay? So he says that if A and B and C are rational numbers belongs to Q, the discriminant is perfect square. Here you have two conditions. A, B, or C are rational belongs to Q. The discriminant is a perfect square. What do we mean by perfect square? That you can write it as a bracket to the power of 2. So if you have the two conditions, then the roots are real rational numbers. Okay? Let's take another example. In the equation 3x power of 2 minus 5x minus 2 equals 0, prove that the two roots of the equation are rational numbers. Here, to prove that the two roots of the quadratic equation are rational numbers, then you have to satisfy the two conditions. The first condition that A, B, and C belongs to the rational numbers Q, and the discriminant is perfect square. Perfect square that you can write it as square bracket to the power of 2, or you can find it as a number has a square root, something like 9, 16, 25. So if the discriminant is perfect square, so the two roots are real rational numbers. Okay? Here you have A equals 3, B equals negative 5, C equals negative 2. The discriminant is B power 2 minus 4AC. Okay? 3, negative 5, negative 2, all of them are rational numbers. We all know that all the natural numbers, all the integers, all of them are subsets of Q, Q, which is the set of rational number. Okay? A equals 3, solution. A equals 3, B equals negative 5, C equals negative 2, all of them belongs to Q. Now we are going to calculate the discriminant, B squared minus 4AC, B squared, negative 5 power of 2, 25, minus 4, negative 4, multiplied by A, negative 2, multiplied by A is 3, multiplied by C equals negative 2. So the discriminant is 49. You can see that the discriminant has a square root because the square root of 49 is 7. So you have two conditions. A, B, C belongs to Q. The discriminant is a perfect square. So you will write that the two roots are real rational numbers. Okay? Another example. If the two roots of the following quadratic equation are equal, then find the values of k. You can find this problem in the school book. Okay? Let's solve this example together first. Then we are going to solve it again by using the PowerPoint. Okay? Okay. Here you can see that A equals 1. B is the coefficient of x equals negative 3. Here the free term C will be 2 plus 1 over k. Here the free terms of x will be 2 plus 1 over k. Okay? 2 plus 1 over k. So the discriminant will be b power of 2, negative 3 for all power of 2, minus 4 multiplied by a, 1, multiplied by c, 2 plus 1 over k. Okay, negative 3 power of 2, it will be equals to 9. Negative 4 times 1, it will be equals to negative 4. Negative 4 multiplied by 2 equals negative 8. Negative 4 multiplied by 1 over k, it will be equals to negative 4 over k. Negative 4 multiplied by 1 over k, it will be equals to negative 4 over k. So now you will find that the discriminant equals 9 minus 8 equals 1. 1 minus 4 over k. In this problem, he says that if the two roots of the quadratic equation are equal, since the roots of the quadratic equations are equal, that is to say that the discriminant equals 0. The discriminant will be equals to 0. So now we are going to write 1 minus 4 over k equals 0. 4 over k, negative 4 over k will go to the other side. So 1 will be equals 4 over k. Cross multiplication, k multiplied by 1 equals k. You will write equal, and 4 multiplied by 1 equals 4. So you will find that k equals 4. Okay? Let's solve it again by using the PowerPoint very quickly. Here we write the quadratic equation in the standard form. Okay? A equals 1, b equals negative 3, c equals 2 plus 1 over k. The discriminant b squared minus 4ac equals 0, because in this example he said that the quadratic equation has two equal roots. The two roots are equal. So the discriminant equals to 0. The two roots are equal. Okay. Substitute equals 0. You will find that 9 minus 8 minus 4 over k equals 0. 9 minus 8 equals 1. 1 minus 4 over k equals 0. Negative 4 over k will go to the other side. So 4 over k equals 1. Cross multiplication. So k equals 4. Okay? So k equals 4. Thank you so much. This is the end of our third lesson. Okay? This is the end of our third lesson. The first lesson is solving quadratic equation by using factorization, by using general formula, and by using the graphical solution. Okay? And our second lesson was solving complex numbers. Introduction to complex numbers. The second lesson was introduction to complex number. And this is the end of the third lesson, which is determining the types of roots of the quadratic equation. Thank you so much. Until we meet again next time, goodbye and good luck.